Thank you, Dave. So we're moving up the food web again here. So Lars started out with the food for the little fish, and I'm going to talk about the little fish, which are the food for the bigger fish, of course. And I'm afraid you're going to see more down arrows. I'm sorry. That's just the way it is. So there's for each of these components of the State of the Lake report, there's a community objective. There's some kind of objective for every element that we look at. So the one here is fairly vague. It's maintain a diversity of prey species at population levels, match to primary production and predator demands. Well, one of the problems with this is we don't really know, we can't pin down primary production, how it's changing so quickly, or predator density. So we don't really know enough about either of those to say whether our prey fish fit in the way they're supposed to, but we try the best we can. So I got several objectives. I'm going to report the results from two surveys now, bottom trawl and acoustic surveys for prey fish. What we always do every year is estimate the annual biomass indices, and I want to stress those are indices. It's not telling you exactly how many fish are out there. It's an index. It's comparable from year to year. And in this special case with the State of the Lake, as Laura said, we're comparing the last two reporting periods and then look at that in context of the long-term trends in the biomass. We're only reporting biomass here, not abundance, because we've got too many, with two surveys and all the different species, it's just too much to look at both in this amount of time. So we got, as I said, two surveys here. These things represent the transects, acoustic transects that were done in 2017. Now this varies every year, they move them around at random. But the red circles here are the trawl locations, so you can see they're all in the main basin, and majority of them in Michigan waters, except for Goderich, Ontario. So that's the coverage of the survey. Now these two surveys target different components of the fish community. So the bottom trawl, we have a long-term time series from 1976. Very rare to see data sets like this that are over 40 years long. This is a rare thing in our world. This targets what we call benthic or benthopelagic species, so species that are smack on the bottom or spend most of their time near the bottom. And those are all these species here. And the other survey only runs back to 2004 in its modern current state. There was 1 year done in the 90s, but I'm not completely sure it's very comparable. This focuses on species that spend their time off the bottom in the water column. And some of them you'll see here, the ones in gray, do both. So they're both, depending on the time of day. Now the acoustic survey is done at night. That's when most fish tend to come off the bottom. A lot of these fish, especially younger ones, will spend a lot of time on the bottom during the day to avoid being eaten by other fish, and then at nighttime they move up and feed. And so we catch them during the day and they catch them at night when they're up in the water column. Emerald shiner is a species that only gets covered by the acoustic survey. So I'm going to start writing with the data. This is alewife. So in every graph like this, you'll see on the top this is the young of the year, so the fish born that year. And then the one on the right for the first three species will be the yearling and older, so everything older than these guys. In the top panels, you'll see the entire bottom trawl time series with the latest two reporting periods here, and then with the long-term mean of all the years before that. And then in this lower graph, you'll see the latest, this area here since 2004 chopped off and focus in on there with both the trawl and acoustic results compared together. And the acoustic results will always be a dashed line, and the bottom trawl will be a solid line. So you can see there was a lot of the time, what did you call them? The time shifts that Lars observed occurred around here. Right around 2003, 2004, 2005, and that's exactly when the alewife crashed too. So you can see the young of the year crashed a fair bit, but the adults basically crashed to zero, and there's no sign of recovery here whatsoever. There's no real difference between the last two reporting periods because they're both basically zero. And this is a curious thing. So you see now the acoustic survey here, these hollow symbols and the dashed lines. They see fewer alewife even than the trawl, which is unusual. Basically, the results for the young yearling and older alewife in the previous reporting period are almost all zero, actually zero. They didn't see or catch any. whereas we catch a few. So if you look at the bottom trawl, it seems like this latest reporting period is slightly lower for both age classes than the previous one. But for the acoustic survey, there's basically no difference because they're all zero. So I don't really understand why we don't see any in acoustics, but it may be where they're sampling. And so some of these numbers, as I say, they're indices, they're an index in each one. So basically they're only comparable to each other. So the years that we're looking at now, you can only compare them to the previous years, you know. And this doesn't really represent what's going on in the lake, because this is a number that summarizes all the fish you catch in the entire lake. And these lakes are huge. I mean, I think we tend to forget that because we're familiar with them. But the shoreline of Lake Huron is over 3,500 miles long. That's the distance between here and London, England. It's a huge lake. So, I mean, you're trying to summarize all this in one number. It isn't necessarily the best way to do things. But you can see that most of the alewife here were caught. And these are only results from the trawl survey, is again because there were no fish caught in the acoustic survey. You can see that they're mostly concentrated, the young of the year and yearling and older up here. So the rest of the lake has basically none. And up here we see a few. And this makes me wonder whether some of these fish are coming in from Lake Michigan rather than being from Lake Huron. But the problem is that yesterday I saw the Lake Michigan talk, and there's not that many alewife in the northern part of Lake Michigan either. They're mostly in the southern part, so it may not be a good excuse. I saw a talk last summer by Rick Barbiero, who Lars mentioned, suggesting that the production in the lake, if you look at it on a smaller scale than the whole lake, is actually concentrated up here. So there's more chlorophyll and stuff up here than the rest of the lake. So that may have something to do with it too, but I don't really know. Smelt, we'll move to smelt. Again, young of the year, yearling and older, trawl survey, 2 surveys together for the last 2 periods. You can see that smelt have declined. The young of the year smelt have declined since the last reporting period. The older smelt has declined slightly, but not that much. We tend to see more young of the year smelt in the trawl by the solid line in the dark symbols than in the acoustic survey here in both of the reporting periods. But the opposite is true for the yearling and older. So the acoustics survey picks up more, and they're both, the difference is similar between the 2 periods, and they're both higher in acoustics, and there's a decrease overall in both surveys over that time period. So not good news for smelt. The smelt, most of them again, now this is both surveys again. This is the survey, the trawl survey and acoustic survey. A lot of them are seen up here again, just like alewife. We see a few at Goderich. In the acoustic survey that's similar, they see a lot here, but then most of the smelt they see are in the North Channel. So the North Channel seems to be completely different as far as smelt ecology goes than the Georgian Bay or the main basin. Now we're going to talk about bloater, the native fish, the native prey fish that used to be important to most of the predators. They appear to be going up, the young of the year. Now, let me go back to the smelt graph. I wanted to point something real quick. One thing you'll notice here is that the recruitment of young of the year smelt, I mean the numbers of young of the year smelt seem to have gone up since this period. And that's the same is true for bloater. We have, in fact, here, this year was the highest we ever observed, and these 2 are higher than anything we've seen before. So it's quite sporadic, but it seems to be there's a lot of juveniles being born, and some of them appear to be surviving. So we had this big peak in 2012 here of adult bloater, and then it went back down again. So for the 2 surveys, the bloater, we see more bloater in the bottom trawl than in the acoustics for the young of the year. And see, the acoustic doesn't appear to be picking up these big peaks. The acoustic survey doesn't seem to be catching those. I don't understand why that is either. But for bloater, the acoustic survey captured more in the previous reporting period, but the trawl survey has captured more in the recent, and that's probably because of these 2 high numbers here that the acoustics didn't pick up. Now, bloater are distributed throughout the lake according to the acoustic survey here. And we're catching most of them in the trawl down in the southern part of the lake, and then several here. So this is the opposite pattern we saw for the other 2 species as far as their distribution goes. And there seems to be fewer in Georgian Bay, opposite to smelt. Okay, so sticklebacks. Now this is a little bit different because the trawl survey picks up mostly 9 spine, and the acoustic survey picks up mostly 3 spine. So this is not really totally comparable, but this is the best we have for sticklebacks. They too have decreased in the trawl survey, continually decrease over time. And we see more of them in the trawl than the acoustics, but there's also evidence in the trawl survey that it's gone down. So these guys are continuing to go down. This is a long-term decline. You know, I mean, this is a peak back here. It's just gone down, right? Sculpins, we don't have any data here from the acoustic survey. These fish are smack on bottom, and so we don't see them in the acoustic survey. They have gone down. Looks like there's been a slight increase for slimy sculpins in the last reporting period here over that one, but not for deep waters. And again, this is look at the patterns here. You see the peak was just like the last species. It was like this. It's going down since the mid 90s. And then this is trout perch again. You see a high peak in the mid 90s here, and a quick decline, and then no real change between the last two reporting periods. And it's really interesting if you look at these species together. This is they're adjusted for abundance, you know. So there's one is the max. They all declined at almost exactly the same time, and it was between about 98 or so here and 2004. I mean, this is before the alewife collapse and before a lot of this evidence of oligotrophication that that Lars was talking about. So this is just interesting that these four species, they're all sort of benthic, mainly, have all gone down at the same time. This may be due to the mussels moving and just crowding them out, you know. Really don't know, but it's just interesting the declines are so similar. Now, around Goby, I don't think that we sample these very well. If you look at the numbers we catch and then the numbers that have been reported in the literature from places in the Great Lakes, we're not catching anywhere near these things. So, and these fish tend to go on rocky substrates and hide in the crevices and stuff. And our trawl survey is limited to basically bare sand. You know, we sample only very smooth areas. Otherwise, we lose too many nets and they get torn up by obstruction. So we have these specific trawl paths that we follow every year that are basically sand. So the numbers here are not, especially this species, are not necessarily representative of what's out there, but you can see the trends. And so it looks like we've had an increase. So the species didn't come into the lake until 98, so we don't have all that older data. But you can see that it's bouncing around a lot. Probably because, you know, these fish also tend to reside in the near shore in the summer, and then in the winter they will move offshore to where we can catch them. So depending on the time of year, the temperatures and all that, in some years they may not have moved out yet, and we may not have a chance to get them. You know, depending on, because the water at the bottom of the lake stays 4 degrees all the time, basically. And in shallower water, it gets much colder in that winter, so they're going to move off to where it's deeper and will be actually warmer than the shallow near shore in the winter. So, so here we have an increase over the last reporting period, but I'm not really sure how good these data are. Emerald shiner, there's been some suggestion that these fish were lower previous to 2004. We don't really have any data on that. This is only the acoustic survey that catches these fish. And so it looks like they've gone down slightly since the last reporting period. But it's bounced, you see it bounces around quite a bit. And so some people have suggested, as I said, that these fish have gone up in abundance when the alewife were gone because they don't get preyed on by alewife anymore. But we really don't have much data to address that. And here's the percentage or the proportion of the biomass percentage here as exotic species. So you can see that the long term we had high percentage of abundant, almost 100% back at the beginning of the survey. It's slowly gone down, popped back up sort of as gobies came in. Now it's gone back down again. We lost alewife and smelt. So in the last reporting period, the bottom trawl suggested it was a 40-some-odd% exotic species, and the acoustic survey said somewhere around 30, but lo and behold, our surveys actually completely agree here. So I'm going to focus on this point. Surveys are saying the same thing, 28% of exotic. So this is a good thing. According to one of the management objectives for the lake is that we have fewer exotic species. So this is good, and it seems to be getting better over time. This is lower now than the previous reporting period and much lower than the long-term mean. So we're heading in the right direction as far as that goes anyway. That's one good point. Now here we go. This is the total biomass. And I want to make the point that we expect differences here because we're sampling different fish species at different places in the water column. So we do not expect this, certainly this metric to be the same between the two surveys. But it's not too bad, it's not too far off. You know, here's the long-term trend in the trawl. And it looks like there's been a bit of an increase in the total prey fish biomass in the last reporting period over the previous. And you see it down here better when you zoom in on it. And in both cases, the trawl is telling us we have more fish than the acoustics, but the difference is not very big. And so, in my opinion, these surveys are pretty, pretty much in agreement. You know, I mean, they agree with each other pretty much that you see the same kind of patterns over time here. And so it looks like we have an increase from the last reporting period, which is good too. So maybe things will get a bit better. And so, as Lars was discussing, I mean, I don't want to get into this too much. Everyone knows that we think there's probably been a regime shift in the lake caused by these mussels. So this is our trawl. Trawls are full of mussels most of the time, depending on where we are. And so we need to recognize that and plan for the future based on that kind of thing. As Lars said, these lakes probably aren't going to support as many fish as they did for a while anyway. I mean, there's no sign of change really right now, so we better get used to it. So in summary, total offshore prey biomass is still low. It's higher than this reporting period, so it's gone up a bit. There's no evidence of any kind for any kind of alewife recovery. We had high bloater estimates at the beginning of the reporting period. They seem to have been reduced since. The biomass indices for all the species are low, still, relative to the historic data. We're not making much progress towards that prey fish community objective if we're not seeing any increases. The lake may have undergone a regime shift, and as Lars said, it's becoming more oligotrophic. It may not be able to support the fish biomass that it did. We've got evidence for increased YOY smelt and bloater abundance. We don't know why that is and why the acoustic survey is not picking it up, but that's interesting. That may, if some of those fish begin to recruit, we may be able to see a higher density of adults. And in my opinion, the results from the two surveys generally agree. And I want to, this was supposed to only go through 2017, but I just couldn't do it without showing you the 2018 numbers. So the 2018 prey biomass is 3 times what it was in 2017. So that is a good sign. And it's mostly bloater. You can see this is bloater here, this color. And you can see that big peak in 2012, and there's another one here. So we've got, that's mostly bloater. The fish community is about 45% bloater now, adult bloater. So this is a good sign, I think. We'll see how it plays out. But I wanted to leave you with a positive, on a positive note. And I'll take questions.